Hello everyone. So I'm Kevin, and I'm now independent. And MPCStats is a project I was working on while I was still in PSE. And from the name, you can tell we use MPC to compute statistic operations. And we guarantee the input privacy and also the output correctness. And the project is now sunset. So this talk is more like we summarize and we talk about what we've built and how we built it, and also what we have learned. So hopefully it'll be useful or helpful for you or people who want to build MPC applications. Yeah, so first, why do we need privacy-preserving stats? If we want to compute some statistics from input from different people, the naive way is to let them submit their data to a single server like this. But there's a problem. The server learns everything about the data, which is not good, and some people might not want to do it anymore, and probably due to the regulation. So if we can make it not leaking data at all, we can probably unlock more use cases. And here is what MPC is helpful. So MPC stands for Secure Multi-Party Computation, and in MPC, basically, there are multiple parties like this. We have 3 parties, and they collaboratively compute some result without revealing their own secrets. And at the end, all parties will be convinced the results are correct. And what is different from the single server scenario is that the trust is different. We don't trust the single server anymore. Instead, we trust the threshold. So for example, if we assume parties are honest majority, which means most of them are honest. So as long as most of them are honest, our inputs are secure. But if most of them are malicious, your input might be revealed directly. Yeah. So what is our project, MPCStats? So originally we wanted to build a generic platform, which is open to anyone. Everyone can share their data and query stats from data from others. And inputs remain private, and the computation can be arbitrary, something like that, which is quite ambitious. But we realized our goal was too large, too broad, so we decided to scope down because we didn't know who will be our user and how arbitrary computation will we need to support, something like that. So that requires a different technical feasibility. So we decided to scope down to build a smaller demo, which is the DevCon demo we built. And we picked a specific use case and just to test the technical feasibility and to get some feedback early. Yeah, so we let the participants to contribute, to share their Ethereum balance on Binance, and we compute the stats. So this is our dashboard. We have some stats here, and no individual balance was revealed at all. To build the demo, we use a framework called MPSpeed, which is quite popular and well maintained. And another some reasons we are using it is that it's easy to write the computation. So you can define your computation with Python. Like the left-hand side is computing the average of the inputs from 3 parties. And also the framework support many MPC protocols given different trust assumptions like this table show. And we can easily use the same code, Python code, and we can benchmark with different MPC protocols easily. And to make the UX better, we decided to delegate MPC to the 3 servers. So which means users didn't need to run MPC themselves. They delegated to our 3 servers. And it is the feature supported in MPSpeed. If you're interested, you can check it out. And it makes the UX much more simpler. And users only need to submit their secret share data to the servers, and they can go offline. And let me explain further. So originally, without delegating MPC to servers, all the data providers and consumers who query the computation, they need to be in MPC, like this. So if we have n data providers, they all need to be online with their consumer. Yeah, so the pros is that the data consumer who query the computation, they can be convinced the result is correct. But the cons is that they all need to be online. It's hard if there are many data providers, and also the computation overhead, like multiplication, it grows with the number of parties. So in this case, is the number of data providers. So if we get many data providers, the overhead will be bad. So with delegating MPC to 3 servers, the n data providers, they just share their masked inputs to the 3 servers, and servers compute, and the consumer get a result. And the pros, the pros is just the end user, like data providers, data consumers, they don't need to be online. Like they just need to interact with the 3 servers, and they can go offline. But the cons is that they all need to trust the 3 servers for the input privacy. So they need to trust the 3 servers don't collude to reconstruct their plain text data. And also they need to trust the servers that they don't compute something else. They compute something correct. Yeah, and another feature we supported was input verification with TLS Notary. So one major problem in MPC is that you couldn't tell if a user lies about their input at all. So for example, if we want to compute some stats, someone can just input garbage value and you get garbage result. So with TLS Notary, users can prove their balance on Binance and get a TLS Notary proof. And MPC parties, they just check if the inputs match the TLS Notary proofs. And if so, if they match, it means the inputs are authenticated. They are indeed from Binance instead of some random value. So we can be sure that the outputs are correct. Yeah, to summarize a bit about our MPC settings and performance. So we had 3 servers in the same region, and it was T3 in AWS, which is quite normal machine. And we use the honest majority protocol, which means it's secure when at least 2 parties are honest. And both sharing data and query computation takes under a minute, so it's acceptable. Yeah, and we got some feedback. So in total, we got 19 data providers across DEF CON last year, and also Taipei Blockchain Week later last year. Sorry. And most of the participants, they were okay with the 3-server trust model, probably because Binance balance is not that confidential. And some people, they didn't want to participate because they are concerned about generating API keys, which is required by our script. And also some just doubted if our script do something bad. And I think that's understandable because Binance is financial and probably it's difficult if they lose money. Some lesson learned. The first, even though we validated the technical feasibility, we think use cases are the most important. So if you want to build some MPC applications, I think it's the best to make sure what you're building makes sense in the real world scenario. So for our case, our demo is just using Binance its balance and probably get some stats, but we're not sure if the stats make sense to others. So it'll be best if you can find a real world use case and use MPC to solve it. And second, trust and usability are critical for adoption. So to make user use or run your script or code, you need to make sure to convince them about the what's happening behind your script, so they can trust you and they'll be willing to participate. And also UX is really important. So make sure your script runs fast and you don't need much configurations, and probably the web-based will be the best. And the third, the data sensitivity affects acceptable trust models, which means in our case, Binance balance is private, but it's not confidential. But if your use case use some data which is really sensitive, you probably need a stronger security model. Yeah, so these are the directions we wanted to explore. We didn't do it. We didn't explore it in depth, but we think it's interesting. So the first is that if we support more data provenance tools, we can unlock more use cases. So for example, ZK email can let us integrate inputs from email. And if you want to enhance your security, probably you can consider using FHE, MPFHE, something like that. And because we're using 3 servers delegating MPC, so we don't have verifiability. If you want to bring it back, you can consider using TEE or CoSNARS, etc. And that's it. Yeah. So even though our project is sunset, our code and documentation is still there. So this QR code is to our document. And if you want to reuse or adapt our code, you can just follow the documentation. And that's it. Thank you, guys. Oh.
So does anyone has any questions? We're open to QA now.
Hello, a quick question. So if you have like a tree dedicated server and the clients go online, isn't this basically a glorified client-server interaction?
Sorry?
So if you have like three delegated servers, and I'm a client, I go offline and delegate to the server. Like, what is the difference between that and a normal client-server communication? Because from the client's end, it might not even need to care whether it's three servers or just one server. It could also be a Kubernetes setup. Yeah. Or even like a single server. To the client, it doesn't appear that it's three servers. Like, how is this communicated to a client?
Yeah. You mean what's different from submitting data to the three servers, right? Or
yeah, like how is it made apparent to a client that it's an MPC setup, which is more secure versus just a normal server?
Yeah. It's so when we use three servers, there are providers when they submit their data, the data is actually masked. So the three server couldn't reconstruct one server cannot reconstruct the data themselves. And also the client interface feature in MPSpeeds guarantee the output from the MPC by three servers. How to say that? So the security is the same as the MPC within the servers. So clients can detect if servers want to cheat about the output from MPC. So I think that's, I'm not sure if I answered your question. Okay, sorry. Probably we can talk later. Yeah.
Okay, I think we can have like more questions. Has anyone has any questions?